Good day. So in this video, we're going to be talking about hyperbolic functions or hyperbola functions, right? So we're just going to be breaking down what some of the variables in a general formula of a hyperbolic function means or does to the graph, and etc., right? So let's just jump straight into it. So our general formula for a hyperbolic function is this one right here. Let me just use a different color. It's this one. This is our general formula to a hyperbolic function. So A right here at the top basically tells us which quadrants the function lies on, right? So we know that a hyperbolic function has two graphs. It has two graphs that are drawn, and when A is positive, our graph will lie on the first quadrant, which is this quadrant right here, and the third quadrant. So your graph will look something like this, basically. How this two black graphs are drawn here. Whereas when A is negative, our graph will obviously lie on the second, where it's here, the second and the fourth quadrant. That's where our graph would lie. So basically A tells us which quadrants our graph lies on, or the function lies on, whereas Q, the value of Q, is our horizontal asymptote. So for those that don't know what an asymptote is, a point on the graph where the function cannot touch that point, right? So hypothetically, let's say Q was 2. We say the value of our Q is 2. So what we're going to do is we're going to draw a horizontal line, obviously on that point 2, like this one here. We're going to draw a horizontal line, and however we draw a function, we should make sure that our graph should never touch that point. So that's what a horizontal asymptote is a point on the graph where the graph will basically be undefined, and it should not touch that point in a way. P is the same. It is an asymptote, but P is our vertical asymptote. So let's just also try to draw a vertical asymptote. Let's say, for example, we had a value of negative 3, right? So we're going to draw a vertical asymptote, which is a dotted line going down, intersecting that point 3. I'm sorry it did not intersect, but yeah, intersecting that point 3. And what I'm basically saying is that however I draw my graph, I should make sure that those 2 points should not touch the graph, right? So let me show you how I'd maybe draw my graph if maybe those values of Q is equals to 2 and P is equals to negative 3 were there. For example, if my A was positive, meaning that my graph should lie obviously on the first quadrant, I'd draw my graph somehow like this. It will go straight into this point, but I should make sure that it never touches that red line, that red dotted line. So my first graph would obviously look something like this, and then my second graph would obviously look something like this. Something like this. So this would be how my graph looks if my asymptotes were 2 and negative 3. So the last thing that I want to touch on is what we call axis of symmetry. So axis of symmetry is basically straight lines that are drawn that cut the graph in half, or that mimic a mirror line of the graph, right? So for example, if these blue lines or these blue functions were my graph, I had to draw a line, a straight line like this, that tries to cut the graph in half. I know that it doesn't really cut the graph in half, but basically it's separated into this side and this side right here. So that's what axis of symmetry is. It's basically something that cuts something in half, And in hyperbolic functions, we always have two axes of symmetry. We have one that's a decreasing function, just like the one I've drawn, and another one that's an increasing function, obviously starting from this point going up. So you have two lines that are increasing and decreasing functions, right? So there is a general formula to drawing these two lines, and the general formula to drawing those lines is y is equals to x minus p plus q. Y is equals to x minus p plus q. And the second one, let me just try to use a different color. The second one says y is equals to minus bracket x minus p close brackets plus q. So obviously you're going to have the values of p and q in order for you to define or write down the equation of that function, and then you're obviously going to draw it into your straight line in order for you to determine the axis of symmetry and draw everything so that your function can be complete. So that's basically what I wanted us to cover in this video, and in the next video we're going to try a couple of examples that basically self-explain or explain some of these functions. So here we have a question on a hyperbolic function, right? So let's just jump straight into the question. It says given f of x is equals to 2 over x plus 1 minus 3. So the first question says 4.1.1 says write down the coordinates of the y-intercept, right? 4.1.1. So we know that for us to write down the coordinates of the x or the y-intercept, we need to make x is equal to 0. So we know that when x is equals to 0, we're going to substitute that into the equation. Now we have f of 0 is equal to 2 all over 0 plus 1 minus 3, right? And we know that will give us 1, so 2 divided by 1 is 2, minus 3, that will give us negative 1. So we know that when x is 0, our y will be negative 1. So that will be our y-intercept coordinates. So 4.1.2 says calculate the x-intercept. So for the x-intercept of f of x, for us to calculate that, we need to make y is equals to 0, or in this case, f of x has to be equal to 0. F of x has to be equal to 0. So now we're going to substitute f of x as 0. So where there's f of x, we're going to say 0. And then we have 2 over x plus 1 minus 3, right? So obviously we're going to take 3 to the other side. We have 3 is equals to 2 over x plus 1. So now we're going to multiply both sides by x plus 1. Multiply both sides by x plus 1 to get it out of the denominator. So obviously in this situation, these two will cancel out, and then the 3 will multiply the x plus 1. The 3 will multiply the x plus 1, and we're going to have 3 multiplied by x is 3x. And then 1 multiplied by 3 is 3 is equal to 2. And then obviously take the 3 to the other side. Now we have 3x is equals to 2 minus 3. That will give us negative 1. And negative 1 divided by 3. Negative 1 divided by 3. X will be equal to negative 1 over 3. Negative 1 over 3. So when y is 0, x is negative 1 over 3. So that's our coordinate for our x-intercept. X-intercept. Sorry for, yes, actually, I'm right. For x-intercept. So let's just erase that so we have space for the next question. So 4.1.3 basically says sketch the graph of f in your answer book, clearly showing all the asymptotes and the intercepts with the x's, right? So before we try or attempt to sketch the graph, I just want to take you to this page right here, which basically gives you the steps of drawing a hyperbolic function. In many cases, you can use these steps to drawing any form of function. It's just that some functions don't have asymptotes and axis of symmetry. So the first step says determine your asymptotes and sketch them on your graph. right? And then the second step says determine your intercepts and quadrants. So we've already done part of step 2, which is determine your intercepts, which 4.1.1 and 4.1.2 was based on, right? So now we're just going to complete step 2, which is basically determining which quadrant your graph is going to lie on. So we know that our A is basically equal to 2, and obviously 2 is positive, so we already said that when A is positive, our graph will lie on the first and the third quadrant. Right? Quadrant. So step 1 says determine your asymptotes and sketch them on your graph. So we're just going to do that. So our asymptote is x plus 1 is equals to 0. So every single time you want to determine your vertical asymptote, you're going to take the denominator value and make it equal to 0. Reason for that is because, remember, an asymptote is a point on the graph where the graph is basically undefined. So it's not going to touch that point. And we know that anything divided by 0 is basically undefined. So now we're going to take the denominator and say it cannot be equal to 0. So now we're going to solve for x from that. We're going to say x is equals to -1. So x basically cannot be equal to -1, because if it's -1, the denominator is 0 and the graph will be undefined. So that is your vertical asymptote. That's your vertical asymptote, right? So now to determine our horizontal asymptote, that's easy. Our horizontal asymptote is always q. So in this case, q is -3. So that's going to be our horizontal asymptote. Horizontal asymptote. So let's look. So the first step says determine your asymptotes and sketch them on your graph. So we're going to sketch that quickly. Just going to click here, slide down, and try to sketch that. Okay, so now to sketch our asymptotes, we said our horizontal asymptote will be equal to -3. So let's just put -3 somewhere here. This is going to be our horizontal asymptote. Let me just try to use a different color for asymptotes. So it's going to be a dotted line, dotted straight line. I know the lines that I've drawn are not really straight, but you get the point. So it's going to be a dotted straight line, and our vertical asymptote is -1. So -1 will be somewhere around here. -1. So we're obviously going to draw a vertical asymptote going all the way down. Alright, so let's go back to our steps. So step 1 says determine your asymptotes and sketch them on your graph. We've done that. We say determine your intercepts and quadrants. We've already done that. And then from there we can basically draw our sketch. So now it's just time for us to put our intercepts, which we've already done, in 4.1.1 and 4.1.2. So we're just going to put them in our graph. So the first x-intercept was -1/3 and 0. So -1/3 and 0, which will be somewhere around here. Oh, let's just put a cross, right? And then our other intercept is 0 and -1. 0 and -1. So that will be somewhere around here. Somewhere around there. So now when we sketch our graph, let me also use a different color. When we sketch our graph on this quadrant, it's going to start all the way from here, going down, never touching that red line. Never touching that red line. So that will be our first graph. So now, for us to draw our second graph, which will obviously lie on the third quadrant, we need another point, because our intercepts both lied on basically the first quadrant of the graph, right? The first quadrant of the graph. So we need another point. So we can get any other point that's basically after -1. So we can use -2, right? So we can use -2. So in this case, we're going to say 2 over -2 plus 1. and then minus 3. So we know that negative 2 plus 1 is negative 1, and 2 divided by negative 1 is negative 2, and negative 3, that will give us negative 5. So our coordinates for that other point will be negative 2 and negative 5. Sorry, negative 5. Negative 2 and negative 5. So now we're going to find a point where we can say that's negative 2 and negative 5, and that point will be somewhere around here. Let's just put a cross. We'll be somewhere around there. So now when we sketch our graph, we're just going to take it to that point, let it cut, get closer to the asymptote but never touch it, and voila, that's basically our graph, right? So we're done basically drawing our graph from here, and we're just going to move on to the next question. The last step says calculate the equations of the axis of symmetry and sketch if asked. So in this case, they say sketch our graph. Let's just look if they told us anything about the axis of symmetry. In other cases, they can tell you to sketch your axis of symmetry as well. But in this case, they didn't tell us to sketch our axis of symmetry. They just said showing all asymptotes and intercepts with your axis, right? So now the next question, which is 4.1.4, says one of the axes of symmetry of f is a decreasing function. Determine the equation of this axis of symmetry. So this could be kind of tricky for someone who doesn't really understand what they're asking. So remember, with axis of symmetry, we have two different equations in a hyperbola. We have the other one that says negative x minus p plus q, and the other one that says x minus p plus q. So the only difference is the negative that's in front here. It's that negative that's in front. Let me just erase it quickly. Is that negative that's in front. That's the only difference. But this equation right here is what we call a decreasing equation, or it will form a decreasing function. The reason being is that your gradient, that negative makes your gradient negative. Your gradient negative. And we know that with a straight line that has a negative gradient, the graph will look something like this. Right? So for every value of x that we add, our graph will basically decrease. Our y value will decrease. So that will be a decreasing function. So now that tells us that we need to use this equation, which forms a decreasing function, in order for us to determine the decreasing function of the graph. So now we're going to say y is equals to negative x. What's our p? Our p was plus 1. If it's a plus 1, we're going to say it's a minus 1. If it's a plus 1, actually no, I'm lying. We're going to write it as plus 1, sorry. We're going to write it as plus 1. And then with our y, we're going to write it as minus 3, right? So our equation will be this. Negative x minus 1 minus 3, which is obviously negative x minus 4. So that is the equation of your decreasing function. That's your equation of your decreasing function. Decreasing function of axis of symmetry, basically. So they didn't say anything about sketching that function, but if you were to sketch it, it will obviously, in this case, if you were to find your y-intercept, you'd make x is equals to 0, and your y-intercept would be obviously negative 4. Your x-intercept would be, y will be 0, negative x, negative 4. Obviously, we're going to take the x to the other side. Now, x is equals to negative 4. So, where x is negative 4, it will be some point here. Let's say it will be some point there, and obviously where y is negative 4 would be some point here. So you're just going to connect those two dots, obviously, those two dots, and you're basically going to get your decreasing function. So as you see with the axis of symmetry, it basically cuts that graph in half and forms this mirror reflection of the two graphs. Obviously, we didn't draw the graph according to scale, so it won't look like it's a mirror reflection, but you get the point. With axis of symmetry, it has to show like it's a mirror reflection. So that is it for the end of the video. Please go like, comment, and subscribe, and obviously put your suggestions on what you'd like us to post about in our next video. And yeah, See you in the next video.